So hi, welcome back to the Cosmic Classroom. Now we're going to talk about the proton-proton chain. Lots of confusion about the proton-proton chain. Let's see if I can summarize it for you, all right? So the proton-proton chain is one of the ways by which we can fuse atoms of hydrogen, which are simply protons, into an atom of helium. So we'll start with four protons right there. Brought my protons. 1, 2, 3, 4, right? And they will combine to form, at the end of all of this, a lot of stuff is going to happen in between, but they will, at the end, become an atom of helium, which has, 2 protons and 2 neutrons. Now, for fusion to occur, remember that these particles need to be moving really fast because the protons are both positively charged. So if they get close to each other, they will end up repelling and move away. So they need to be traveling super fast to really get close to each other. That's why fusion only happens when you have very high temperatures and very high density, so that those protons are smashing into one another. Now, let's consider at first 2 protons. What happened to 2 protons? Because what happens is symmetric. Those 2 protons will combine and those will combine. So let's talk about those first. Let's start with these 2 protons. The first thing that happens to these 2 protons is they combine, and then they become something that's called deuterium. It's a heavy atom of hydrogen. Still hydrogen because it only has 1 proton, but it's a heavy hydrogen atom. So this is deuterium, and these are the 2 protons. Now, something is missing from this equation, right? Because you can see that in here we have 2 charges, 2 positive charges. In here we only have 1 positive charge. So something has happened. Actually, more than you can tell has happened. One thing that has happened is that this charge must be somewhere. The charge goes and becomes something that's called a positron. Oops, a positron is an electron with a plus in there. That's a positron. A positron is the antiparticle of an electron. It's an electron, but instead of being negative, it's positive, all right? So that's one thing. What also comes out from this reaction is a neutrino comes out of that. That's something else you haven't heard about until today. So that's the electron neutrino. There's more than one kind of neutrino. It's an electron neutrino that it's created. And there's also some energy, right? Some energy that are going to be gamma rays that will be created. So for a proton to become a neutron, it needs to get rid of some charge, and it also ejects a neutrino and some energy. To really go from 4 protons to 1 atom of helium, there are different ways, different paths to be taken. What I really think it's important is to understand that the 2 will combine, the other 2 will combine, and then at some point they will combine together and will become this atom of helium. So this happens twice here. So because it happens twice, I'll actually have, every time 1 atom of helium is created, I actually have 2 positrons, 2 gamma rays, and 2 electron neutrinos. And what goes wrong right here in the middle, it's really not that important because there are different ways for this to happen anyway. So the book tells you one way, which happens frequently, but there are many ways. So for everything to happen, this is going to repeat, and we're going to have 2 of each particles. This is the proton-proton chain. Now, there's something very interesting happening here. There are 2 things very interesting, right? First thing is, you never knew that a proton can become a neutron, did you? A proton can become a neutron plus a positron. In fact, a neutron left alone decays into a proton plus an electron. So this is something that is strange. The other thing that's funny is that, let's say we get these 4 protons here and got this atom of helium, and let's put them in a scale. There's a scale. It turns out that this combination of 4 protons is heavier than here. Okay, so it has more mass. This will be heavier than those. Now think about it. The mass of the neutron is approximately equal to the mass of the proton. In fact, if you go look in your old chemistry book, you'll find out that the mass of the neutron is slightly greater than the mass of the proton. How is it possible then that the helium is less massive than the 4 protons together? It's like saying that you had 4 bananas and you divide in 2 bananas and 2 bananas, and then suddenly the mass doesn't add up. They should add up. It doesn't add up. What's going on here? Because you hear everywhere, oh, everything. What's happening is that the energy that's coming from that energy emitted from the sun is generated by nuclear fusion, because this is lighter than this. This has less matter than that, and the difference in mass of the helium minus the mass of 4 protons is transformed in energy. So the energy is the difference in mass, is mass of the helium minus 4 times the mass of the protons times c squared. But how is it possible? Now you need to start thinking about, what does mass mean? What is mass? Mass is how hard it is to put something into motion. If it's hard to move something, it has a lot of mass. If it's easy to move something, it doesn't have much mass. It turns out that because of the way this atom becomes bound together, it's easier to push 1 atom of helium than it is to push 4 atoms of proton. It's the same material, but once they came together, it became easier to make it move. That's why we say that it has a smaller mass. It's the same particles, but those are bound together. Those are moving as 1, or those are moving as 4. So I hope you find this as interesting as I do. I think this is fascinating. 4 things that should be exactly the same, they are not. And then we're talking about nuclear fusion, and it all comes back to Newton's second law, F equals ma. What is m, right? M is how hard it is to push on something. I find it fascinating. I hope you can share that with me. And I'll see you next time.